All right, welcome to Hawk Podcast 33. We're continuing our data center fundamentals series. This is our fourth one. Today we're talking about data center infrastructure. David, so all of the things that make a data center what it is.
Yes.
So if I were to ask you in one simple short phrase, what is data center infrastructure?
All of the components that make the data center.
God.
No, I mean, this is the...
Brilliant answer.
Yeah, no, this is the... the electrical, the mechanical systems that, allow data centers to function properly. And we'll talk about it here in a little bit of how those have changed. But if you're starting in the industry, and this goes back to our intro to our data center fundamentals course that you can get online, these are the things you need to understand at a high level to grasp how data centers function so that you can, see why the industry is moving around things like data center design and why these things are changing, data center, like facility size, all these things that come into the envelope of a data center are part of the infrastructure.
Great. So, when we were talking about this the other day, you said you like to think of this from an outside-in approach.
I do,
So
Mike.
I think
yes.
Starting with, the extreme outside, like starting with you're at the street view of a data center. Yeah. Right there. What's going to be different than, a different type of facility, an office building, a retail building? Like, what are we going to see right off?
Yeah. You'll typically see, and this is, I think we've talked about this before, and it's not really within the infrastructure side, but you will see some sort of security, perimeter security, like before you get to the building. But I think actually one of the interesting, as we kind of work outside in, when I started in like the real estate space, one of the things that drew me to the data center industry was the amount of capital that it takes to build a data center because of the expense in the infrastructure. And, if you take the data center facility that's 100,000 square feet and compare that to an office building, it's traditionally like 10 times more expensive to build that data center building than it is the office side. And so it's a fascinating. That's what makes the data center industry really interesting. Is it's a smaller commercial real estate market, but it's so much more. There's so much more money in it. You'll typically see the security, and then as you, kind of work your way in, the first thing you really have to come to grips with is the power infrastructure, and that is what companies, when they are leasing data center infrastructure from a data center operator. When they are building this themselves, it is the need for power to support their servers that they have to figure out what to do with. And so this is in essence what makes these buildings so expensive is you got to figure out from a power perspective, how to bring that power to the building. That's typically from like transmission lines on the outside to substations to transformers then to, your utility power coming into the building. And then that will bring you into things like the UPS systems. There's backup generators that support the power systems within a building. So if the power goes out, the generators will come on and support the building even if they don't. Yes, I've been...
Yeah, no, you're great. So,
David,
I think a great way that I understand this is like you think of it like a laptop like I've got here where you plug something into the wall, there's that little box which changes the type of power, either from 120 volts, whatever's coming out of the wall, to something that your laptop can use. Yep. And then subsequently, you've got a battery in here as well. So if that power gets disconnected, it's going to automatically switch over. It's the same thing that happens in data center. Like they've got power at some voltage and amperage rating that comes from the utility, comes in, change it to a format that the servers can use. Yeah. And then in addition to that, everything that's set up that if that power for whatever reason fails, and sometimes they've got multiple of those, or two of those, and if any of those fail, there's an immediate cutover to either battery or generator or whatever, and they're all set up for like certain loads and certain amounts of time.
Yeah, and it's power.
So that there was always power to the server.
Yeah, and it's broken down basically from big to small so that it can serve what, it's essentially what you do in your home too. Your power comes into the city at X and it just gets broken down so that you can use it at your home. And so that's what's happening from a data center perspective. One of the things that makes it so capital intensive is the redundancies that are placed, which you mentioned. And, I would tell you if you've been in the industry, if you're listening to this, you've been in the industry for a long time. I think you would agree that redundancy, the importance of that, has changed over time. 10 years ago, you would hear the term like tier 4 data centers. There's a tier ranking typically. Tier 1 is your lowest redundant data center, all the way up to tier 4. And tier 4 is your highest redundant data center. So there was a long period of time where companies were really trying to build those tier 4 data centers, most expensive, most redundant. And then they realized that, we can really get by with like tier 3, that a tier 3 redundant data center from a power perspective, from a cooling perspective, which we'll get to, really satisfies our need for redundancy. But it is that infrastructure that is so expensive, and really understanding how to build that and to deliver it in a timely manner is what's changed the market over the last several years.
Yeah, you touched on something that's interesting. Like at a data center operator's core business, they are providing for you a secure space with reliable power and reliable connectivity, right?
Yeah.
And so, jumping back to, the physical security of a building, talk a little bit more about some of the measures that these companies put in place and why they're there, as far as why the customers need that security.
Well, a lot of it is perception. The reality is there's not a lot of people breaking into data centers from a physical standpoint, but these are the most critical operations for companies today. And the more important, I think we'd all agree that data is becoming more and more important. What you do with data, how you use it, your company's internal data is like, as our world grows, technology grows, that's becoming more and more valuable, more and more important. So, the levels of authentication to get into an actual, area where servers are kept and the IT infrastructure is running, typically it'll take like 7 checkpoints to get in, outside security, inside security, card key access, biometric scanners, all these different measures in place to make sure that whoever is physically in these servers rooms should be there. And that's really the point of the physical security.
One of the more unique features of a data center facility is called a man trap. Talk a little bit about what one of those are and what happens if somebody maybe accidentally sets off an alarm in a man trap.
That's really funny, Mike. This has happened one time in my life. Okay, so essentially a man trap, is a area where, there's an entrance and an exit, and you basically can't open one without the other. You can't open one while the other is open. So basically you open the door, or it allows you in, you're in, the door shuts behind you, then you can go in from, the other area. And there was one time about 3 or 4 years ago, were you with me there or not? Okay. So. Where, dude, I thought I got the okay, come on, and it was a push door, and I pushed it, and I mean the loudest piercing noise, like it's still to my soul. I will never, do that again.
Yes,
so
it worked. It was an appropriate deterrent.
Yeah.
And again, I think you hit on it with the data piece of like,
gives my heart
if you're talking about like a bank or a online retailer with credit card information, they have hundreds of millions of credit cards or social security numbers or health records that, that are on a server somewhere.
Sure.
And you have to be able to protect the sanctity of that server. So I think,
and there's also this like cybersecurity piece, which to be honest is a much more harder, nut to crack as it relates to making sure that you have that protected well.
Way above the pay grade of this podcast.
Sure. And that's, I'm
but
not
it
looking
exists,
to get in
and
that,
it's a real thing, and operators have to address it.
Yeah. And I think, I guess what I want to make is there's probably people listening that are in the space that are saying like, hey, physical security, but there's also cybersecurity, which we recognize. But we're really just talking about the physical infrastructure from a data center perspective.
All right. So we touched on power, and anything else to talk about on the power side as far as its delivery, any of the infrastructure, the pieces that make up that system?
No, just as it is kind of the bedrock for the data center industry. And I think if you're in the real estate business and you're trying to understand the data center space, one of the very important things to realize is like, it is not the space that's what is being sold. It is the power. Yep. It is the access to the infrastructure that is what is most valuable. You can put any amount of power to a degree in any amount of space as long as you can cool it. Yep. That's your limiting factor.
That's a great segue, Dave. Let's talk about cooling.
I'm all about
and what is needed. So again, thinking back to the laptop analogy, I think we ascribe human emotions to computers quite frequently, but when your computer is thinking a lot, and the little fan starts to spin, and the little part where your hand goes gets real hot.
Yeah.
So that same thing that happens in the data center, it's on a much larger scale.
Sure.
When server ramps up and it's doing its server things, it generates heat.
Yeah.
Got to get that heat out of there. So talk about how data centers do that and why that's complex. What's some different approaches that companies have taken to do that?
Yeah, and this is another part, very important part of like the data center infrastructure is the cooling. How will you cool all the heat that you're bringing in? And there's a number of like different technologies and ways to approach this. From just an infrastructure side, you can really cool things from an air-cooled perspective or a water-cooled perspective. So are you using air to cool things, or are you using water to cool, the servers and the heat, or reject the heat in the data center? And each one comes with, more efficiencies on the front end. One is more expensive than the other. So there's pluses and minuses to each. We've seen companies really utilize like air-cooled. The air-cooled approach over the last, 5 to 10 years. There are companies that still do, water-cooled systems. But that and that infrastructure that comes along with that, typically is what takes up space, within a data center on the outside of like in a data center equipment yard.
If you walk through any given data hall, you'll have an aisle that you walk down, commonly referred to as the hot aisle, or the cold aisle, and then space on either side. So if you look at 10,000 square feet of a data hall, probably less than half are physically occupied by servers. The rest is airflow. Yeah,
and there's amazing, I think, technology or innovation that's happening right now within that space.
That's the word I was going to use.
Yeah.
The number of ways people are trying to tackle this specific problem. I think power is more or less what it is.
Sure.
On the cooling side is where you see some really innovative, was the word I was going to use, approaches. People putting data centers underwater. Or weird cooling configurations, or putting the servers in cooled water in the facility. Yeah,
there's different approaches. I think one of the biggest changes that has created a need for that innovation has been the very large workloads that are now being placed into multi-tenant data center facilities or single-tenant data center facilities that, a large hyperscale user would go to a data center operator and say, hey, we want to take 30 megawatts over a 5-10 year period, place them in this facility, and we need you to cool it. And so the data center operator community has become much more, I would say, advanced and innovative in the ways that they're trying to cool things. One, because there's certainly environmental benefits to doing this in a more effective way. Two is because there's been a lot of extra cost wrapped up into a lot of this infrastructure. And so if you can figure out ways to be more innovative, more efficient, and take some of that equipment that's not as efficient out, those cost savings can be passed directly to the end user. And so that is what we have seen. I think we'll continue to see it, in the next 5 to 10 years. But the cool, I think about the data center infrastructure. I mean, I think power, I think cooling, and I think connectivity. So this is obviously a very key component to making sure that data centers run effectively.
Yeah, and this isn't exactly an infrastructure comment, but talk about how, when we see small retail deals, like single cabinet deals, it's typically like, it might be like 2208, a little over 4 kW per cabinet. And so, but we know that there are plenty of folks who are putting 20, 30, 40 kW in a cabinet. So what's driving that density? Because as it relates to cooling, there's going to be some challenges there. But what goes into the decision to put 30 kW in a rack versus 10 or 5?
Yeah. I would say philosophy, like how a company wants to, design their infrastructure to work effectively. Typically what we've had is like enterprise, companies that have built their data center IT infrastructure and then having to transition to that. It's really hard because you have to, you get new systems. You have to see how they work with one another. You have to. It can be a challenging approach. So one thing is to shrink your footprint. So like the data center operator world, they want you to be more dense because they can sell more within their space. The denser your cabinets are. Typically they run out of space before they run out of power. So if you can be more dense in your environment, you typically can get a more, sometimes a cheaper cost, and you can also, then the data center operator will be able to sell more in their facility. So, but what's driving it is typically like the maturity of an organization. Can the actually IT infrastructure cool up that amount of, density is really the biggest challenge. And so you'll see a lot of like creativity as it relates to, hey, we're going to put 500 kW in this many cabinets in this specific area of the data center. We're going to use different cooling methods to do that, and that can work. It just depends on the organization and what they do and what they feel most comfortable with.
And will that typically be like a back and forth discussion between the customer and the data center operator? Say, here's what our requirements are, here's how we think we can make it happen, and then can you make that work for us in this space?
Yeah, absolutely. Like if you're a co-location user and you're going into a data center for the first time, there is, you're going to work with their sales operational team or their engineers to make sure that your IT infrastructure matches their ability to cool what it is that you need to do effectively. So, you've got to communicate with them. And that's what we've talked about before. You can see some of our other content, but it's like you have to pick a partner or someone that you really feel like you can work well with, because you will be working with them. The idea that like you're just going to put your infrastructure in a space and be done, that's just not how it works. So, there's certainly communication back and forth on, here's our plan. There's what's called CFD modeling, computational flow dynamics, that show how the space is intended to work. And so the data center operator will say, hey, what do you have? They'll basically sketch that out for you and then show you how they'll bring the air in and out to make sure that the environment is cooled appropriately. So,
gotcha. All right, so last piece is on the connectivity side. So it can be great, have all the power in the world, totally reliable, it's cooled, but if you can't get the information out, what good is it? So talk about the connectivity piece and how that works from a redundancy standpoint or from an infrastructure standpoint within the facility.
Yeah, you bet. Typically, like fiber is, how that information is, carried in and out of a data center facility, and you have multiple fiber providers coming into a data center facility. Depending on where the site is located within the city might determine how many providers are actually coming in. And so typically you'll have two places within a data center facility where those data center or where those fiber providers are coming into the building itself. And those are called Meet Me rooms or MMRs. So the data center world loves acronyms. So there's one for you. CFD, I gave you another one, so that's two today. I'm sure we'll get to a few more before the end of this. But and then typically you will connect with the fiber provider if you're a user based on who's in the building, and then that fiber will be run from that Meet Me room to your actual caged location or data hall or whatever it is. So that's how the infrastructure works. Like stepping back, that has become a much more important part of the data center industry over the last several years. You can, if you want evidence of that, look at the value of the Carrier Hotel, which is located, strategically in different areas, like one or two per city, and that's where like almost all the connectivity comes to. And that just speaks to the richness of these ecosystems that are formed when not just fiber providers, but cloud providers and different network and peering areas are created, and the more connectivity that is available there, the better it is for different organizations. So, that is a very important piece of things moving forward, and I think it will continue to be like the rest of this year, 3 years from now, 5 years from now, especially as like companies are looking to be more sophisticated with their IT infrastructure and how that serves their business today.
And talk about like the different types of fiber that company might need. There are different types of fiber for different uses that they would need to have multiple kinds, not just from a redundancy standpoint in case one goes out, but to optimize different workloads that they're doing.
Yeah, some could be. Some just have to do with mostly it has to do with how much bandwidth you would need to serve certain types of applications. It probably depends on seasonal spikes in traffic. So if you're thinking of, if you're a retail provider and you see traffic go up in November and December, there might be allocations needed to be made to meet those requirements. The financial industry is another good example of this. If you're thinking of like launching an online banking system that needs to be spread out to different users, how you connect to them and how they connect to your platform is I mean, it's key. We both have kids. They love to play Fortnite and other games. And so any type of, connectivity issues that application has to the end user, which in this case is our kids, their patience level is about this. And so, companies like that are going, hey, we have to meet the expectations of our users. And so, those are a couple of examples, but it's real time. It makes sense when you kind of step back and think about it, like, oh yeah, man, the more I see the wheel of death on a YouTube video or whatever, I go, I don't want to watch that anymore. And so I'm going to be done with it.
It's funny when you start up Fortnite. I know you haven't played yet. I
have not, but I've watched. Yes.
When it has a little logo and it's like checking your connection.
I know where you're going with
this. It says checking connection to data centers.
Yeah.
It says right there. I was like, that's fascinating.
That's right. That's what we do.
Yeah, so I take part in that.
Yeah, so I think the key here is, if you're listening, really understanding the connectivity aspect of data center facilities is really important. And it's not just, the number of fiber providers coming in, but it is things like the redundancy, how many providers are in a building. A lot of end users will have one or two relationships with different fiber providers, and that will be the key driver for their decision. Like, hey, we use this fiber provider in 4 locations, and so we need to make sure that they're in this. So you might have to understand how far that fiber provider is to that data center facility, because they're going to need to be there by the time the end user gets there themselves.
All right. So one of the concepts that's it's a big point for data centers is the concept of redundancy. So redundancy is not a binary concept. So talk a little about redundancy. You talked earlier about tier ratings and how those are related, specifically around the concept of like N+1 or 2N+1. So talk about what that means and why does it matter?
Yes. This is like 2009, and I was working on this is back when I was doing actually like brokerage for a data center client. And I had to fill out this spreadsheet. So I had to look facility by facility. And one of the words was like redundancy. I didn't know anything, man. I didn't know kilowatt, megawatt. I think we've talked about this before. But one thing was redundancy. And I was just basically copy and pasting what the thing said. And so it was like, electrical redundancy, at the UPS, like 2N. And then it was, cooling redundancy, N+1. And so it took a while for it to click. But, basically... So if it seems foreign, there's
just
a reason.
Think back to 9th grade algebra,
sure,
or 8th grade algebra, whenever that was.
Yes. So it's just very strange. But basically,
negative flashback.
Yeah, the N stands for basically like the original need of what it is to support the requirement. And so then as you start to layer on like N+1, that is basically you would have a backup behind the need.
So you may have 5 generators required to power this facility if it goes down.
Yep.
If you're an N+1 configuration, you've got a 6th one.
Yes.
And the assumption then is that probably not all 5 of these are going to go out at once.
Right.
Maybe probably one of them likely will go out, and we've got backup over here to handle it.
Yes. Now at 2N, you would go ahead.
2 times 5 is 10.
That's right. You would have 10. So you'd have the 5 that are serving, and then each one of those would have one behind. And so that costs money. And so, typically the 2N facilities, like that cost gets passed to the end user. So if you're, I wouldn't call it an amenity, but it almost is, because it's just something that, hey, we'll put it in there for you if you want, but you're going to pay for it.
Yeah.
And so what the data center user came back to the provider 5-7 years ago and says like, hey, that's great and all, but like, we don't need that. And so we're not going to pay for it. Yeah. So if you want to keep building it, that's great. But that no longer serves the needs that we have. And if you look at if you listen to some of our other content, we are talking about how the building is changing. The data center operators are building today. It's no longer 1 story. It's 2, it's 3, it's 4. The data center redundancy requirements now are no longer 2N at the electrical level. They're more of like N+1. N+1 at the cooling side of things. And the technology is getting better and better, more efficient, and those cost savings are getting passed to the end user. And that's been this process of the enterprise and the hyperscale world trying to figure out what they need, going to people that build it and saying, this is what we need. Can you do it for cheaper? And can you do it more efficiently? It's not just cheaper, but more efficiently. And that is what we've seen. And because the data center operator world has changed, that's what's grown the market. So if you look at our statistics from 2015 to today, You've seen the market grown. If you look at that commission power number, and it goes in, Dallas from 200 megawatts to 350, in Northern Virginia from, 600 megawatts to whatever it is now, 1.2 gigawatts. The reason why is because of what I just described. And that's only continuing to grow.
Yeah, and I think you hit on it. Like, this is true in any industry that providers or vendors or whatever it is, people who are serving the market are going to try and get more and more efficient. Even if their customers weren't demanding, which in this case they are, they're trying to maximize their profit. So it makes a lot of sense that there's going to be a continued optimization of those efforts.
Yeah.
And so as we've seen, it's generally trended in that N+1 region.
Yeah. And the market's gotten more competitive. You've got more players. There's a lot of smart people in our space. So one of the things, like when people come out with new technology or something that's going to change things significantly, I'm normally a bit skeptical because we have some very smart people from an engineering perspective that are building, and they've done this for a long time. And so, so I always think, and they're looking to change things at this point, almost on like the micro level, that'll have some big macro changes moving forward. So it's, from an infrastructure standpoint, this is one of those things that you have to understand at a high level, because this controls the capital and the money behind, if you're investing in the space, you want to have a good rough understanding of this, because this is why your investments will be much more expensive on the data center side than on the office or the industrial or the retail or whatever it is that you do.
You made me think of one more bonus question I'm going to ask you.
That's great. I love bonus
PUE.
questions. Yes.
I see that. Another acronym for you.
Yes.
Tell me what it means.
Yeah.
And why is it important?
Yeah, it's a as Mike mentioned, an acronym: power usage effectiveness. This measures the efficiency of the the efficiency of the cooling in a facility. So when I would tell you today, this is the number here is less important than it was 5-10 years ago. I'm going to explain. 10 years ago, data centers were probably in like the 1.7, 1.8, 1.9 range, which means they weren't efficient.
So, so tell me how that number is actually calculated.
So it's cooling. It's taking a lot more infrastructure and energy to cool the entire facility than just like the raised floor. So you're being inefficient. Today, PUEs are in the 1.1, 1.2.
It's just a measure of all the power that's required to run the facility. How much is powering the servers versus powering the cooling?
Correct. Okay. Yes. And so this is just a very, just looking at that efficiency number. So from that standpoint, I would say that as data center construction and facility operations has improved, that number has become more consistent among more people. So they've kind of the industry has figured out, hey, if we do X, Y, and Z, we can get the most efficient data center, power perspective. And so that's what we've seen over the last, I would say, 3 to 5 years. So you are seeing like new facilities today, they're going to be, when they are fully commissioned and fully leased or occupied, they'll be in that 1.1 to 1.4 number, and that's pretty healthy.
And as an end user, it's important to note that that's going to be a cost that they're going to bear.
Yeah.
Right? Because they're paying typically for actually the capacity that they're renting.
Sure.
Plus the actual energy that they're using.
Yeah.
So
those
the
are
difference between
along.
1.7 and 1.4 is huge.
Yeah.
Or 1.3. The difference between 1.2 and 1.18, not as much.
Yep.
But if you're a large user, if you've got 10 megawatts of space,
that
could have a huge impact on your bottom line.
Yeah. I think if you're a really small user, what this matters to you is just kind of like, hey, what type of provider am I working with? How important is facility operations to them? Efficiency, kind of at a higher level, because to your point, the cost, the differences aren't that crucial to them. As you talk about, the bigger your requirement is, the more those things impact, because it's direct cost passed to you. And make no mistake about it, this is a cost that the tenant will pay over time.
All right, Dave. Well, thank you so much for all of your insights on data center infrastructure. So if we said this before, you can get this information all through our blog. Just go to datacenterhawk.com/blog, and then there's a drop down for fundamentals, and that's all that content there. You can also get that delivered to you via email. I'm sure there's a sign up that's very apparent if Austin has done his job well, which I know he has, on the site. Or just stay tuned for more of this content to come out in a video format.